Hello again. Sorry for the huge delay between videos, but I guess better late than never, so let's get into it. The main thing we'll be covering in this video is gonna be the ability to add new individuals to the genetic algorithm population while the algorithm is running. However, this isn't something that you will find in a textbook implementation of a genetic algorithm. These are just things that I thought would make it more interesting to use in a video game environment. But before we do that, I want to mention a small adjustment that might be important. In the fitness function, which is located in the test Shakespeare script, down here, where we are calculating our final score value, we have all of these calculations here, which we did as part of our optimizations in the last video. When we do 5 to the power of score, this value of 5 might actually be a little bit too high, which might skew the results a bit too much. So we might want to lower this for, let's say, a 2 for example, or even a 3. And now let's get to the good part. We go over to the genetic algorithm script and scroll down to the new generation function. So if we want to add new dudes while the algorithm is running, the most basic thing that we need to know is how many dudes we want to add. So let's create a new input parameter on this function, and we'll call it number of new DNA elements that we want to add, and we will give it a default value for convenience. And now we need to do some stuff with this new variable we created. We need to know how many elements we are going to have in our population after we add the new elements. So we'll create a new variable called final count. And for the most part, we are going to want to replace wherever we use the count of our original population with our new final count. We only really need to calculate the fitness and sort the population if we already had something in our population. So let's say we create a new genetic algorithm with a starting population of 0, and the first time we call new generation we add 10 new elements. Well, we don't need to calculate fitness or sort anything because there was nothing in there to begin with to calculate the fitness of. We also need to add another condition to this if statement. We need to make sure we don't try to keep more elements than we had in our original population, because now, since our for loop doesn't stop at population.count, it stops at final count, which might be higher. We need to make sure we don't try to, for example, keep 5 elements from the original population when it only had 3. Once again, we need to add a new condition here, and it's going to be the same as above. We don't want to cross over elements if we are going beyond our original population. And now for the part where we actually add something. And here we want to replace this population with new population. So just to summarize what we're doing here, we are creating the population of the new generation of the genetic algorithm. By using elitism, we keep the first few elements of the original population by adding them directly to the new one. After that, we cross over the remaining members, and when we're done with the original population, we just add as many elements as we defined in this variable up here. You might be realizing we could make this code a lot clearer by changing it like this. However, I want to make a small change in just a moment that is much easier to do with a lot less code if we just keep the structure as it was before. Also, as you might have noticed, Visual Studio is complaining about these variables down here, and this is just a very simple fix. We just need to store them as private class variables. And there we go, Visual Studio is now happy. So the change I wanted to make here is to give us the option of being able to cross over the newly added members of our population. And by doing this, we are essentially adding new children of our existing individuals instead of adding new individuals with completely random genes. So now that we're done with the implementation, I'd like to show you a game that utilizes a genetic algorithm and all of the things we've been working on in these last few videos. The individuals are these geometric shapes, and we can imagine them as being workers in a farm gathering seeds. Their genes are float values, and they only have 2 genes. The first gene controls their size, and the larger they are, the more they can carry, but the slower they move. The second gene is going to determine their shape, and each shape has different angles that it can face when it moves. For example, triangles must rotate so that their longest edge is pointing towards the direction that they want to move in. Squares and hexagons must have one of their sides facing the direction they want to move, and circles can move in any direction they wish. There's also different upgrades that we can buy, and some of them are actually to increase the effectiveness of our genetic algorithm, like unlocking elitism, improving our mutation rate and stuff like that. The farm is divided into different sections, as you can see. Each section has 1 worker. Orange dots are seeds that can be gathered. Workers gather seeds one by one, and when they are full, they must return to their initial starting point to deliver the seeds. After all of our workers are done, a new generation starts, which evolves our workers and resets the farm. We can also add new workers from one generation to the next. And so, we just place our workers on the farm, and then let the genetic algorithm do its job and evolve them to be as efficient as possible for each farm layout. And with this, we are done with genetic algorithms. As always, thank you for watching, and see you next time.